So you have the input and output file stream. So the IO stream will give you access to things like couts. And then we've got the F stream, which gives us access to input and output option as far as the file is concerned, right? So in this particular case, if we go into the main function, let me move all this increase indentation so it's a lot easier to see. So in the main function, we've got an output file stream. When we're calling the file, we're calling the object of that my file. So if we go into my file, we want to create a file called example.test. That's what line 6 is saying. And inside that file, you know, this is quite similar to cout. It's the same arrow as cout, so that we used to print to the screen. So inside my file, we want to write writing this to a file, and I'll just say my file here, and I want to print out writing this to console so it doesn't confuse. I think it's a lot better console interface. So all the my file, writing to the my file, we say writing to the my file, and then we just say writing to console, and the cout writing to the console. So it becomes a lot easier. Let me indent the cout a little bit so you actually see the cout option. So we'll print both to the terminal window and then also to the file we create. And this sort of takes us to some of the questions we had in the last session, which had to do with how to create files. So again, we run it, we notice it's automatically created a file for us. Yes, they're writing this to a file, writing to this to a file, writing to this to a file, because we had 4 options of that. My file, writing this to a file, writing this to a file, writing to this to a file. And in the end, we close the file. So it just frees up the buffered memory. And again, we had writing to console 3 times. So it printed to the console whenever we used the cout for that. So I've resumed recording. We're just going to go through a few more, just a few more examples. There's one for int main and other things. I think I'll just try this one out as well. So as usual, we need to include IO stream. And we need to include the file stream, right? Because we want to do file access. So that's the F stream. Can you see my screen? Did I share with you?
Yes, sir.
Okay, good. So I include the F stream, and because we want to use cout, we need to use namespace. So using namespace std. And on top of that, we are going to have our main function. So if I include our main function or driver function, so int main, and doesn't take any parameter this time. And at some point, we want to, let's say, return 0 if we want, but we can just blank it out at some point. So inside the main function, we want to write to a file. So we're going to use the output file stream. So OF string, and we want to create an object of that, and we can call it fout. So if we go into that object, so we take fout and we go into that object, we can open it. So we want to open a file called, give it any name, I don't know, in this case, similar to what we go in the nose, ff.test. The extension is important because it helps us create a file that we can easily open, right? So in the fout, if we're using the object, we can just do exactly the same thing as we do to cout, to write to it. And I'll just say, hello, file. And I can have \n, the same way we handle things in cout. And again, I can do another one to write more to it, to say, welcome to your program, for example. And I'll have a \n again. And that, let me try another one, say fout. I want to write, this is interesting. And I'll close it, fout.close. Let's run it to see if there are any errors. And it's complained about that line. So fix it with semicolon, run it now. And again,
Line 8.
I keep forgetting semicolons. Is there more? Oh, rest and zero. Oh, finally. Yeah. And it created a file called, let me delete these ones because they are in the way. So run it again. And it created a file FF for us. It says, hello file, welcome to your program. This is interesting. You notice that it's kind of handling it as in a similar way as it would handle the stuff in the C out when we use the C out, for example, because it still moved to the new line each time when we put the backslash n. Let's try this. Let's try with end line, for example. Then run it. Go back into the, I need to make sure that it did create the right file for us, and it still worked exactly the same way, ended the line for us. So that's one benefit of maybe the things that are in C out also apply to this. So it makes it a lot easier to handle files when we are doing file handling. I like this code, so I'm going to try it out as well. So again, we are going to be using the F stream. We need the IO stream. We need the namespace. We're going to create an output file called fout, but at the point where we create the output file, we want to give it the name as well. So let's call it right at the point where we create an output file. You notice it's slightly different from this option that we have here. So right at the point where we create the output file, we can call it, I don't know, DD, or that's what's in the notes. So we call it dd.test. So this option also help us create files. It's just slightly different way of creating files. And we're going to have a file or a function. So not a function, let's put a for loop. So what we want to do is we want to count from 4 to 200, and any number that is divisible by 4, by 7, we'll just print it out. So we just say for int I equal to 4 to I less than or equal to 200. Then we do the I plus plus. So in there we say if I is divisible by 7, you know, the modulus operator. So in that case, because 0, because if you divide by 7 and the remainder is 0, we want to do something, right? We want to print out something. Should be best to put this in a quote. So if I is divisible by 7, we want to what? Fout, because it's the file name object that we have created, and we print I divided by 7. Let's say I is divisible by 7. Divisible by 7. And we want to do the new line. And again, we want to see out the same thing onto the screen, the console as well. Let's run it to see whether it complains. I don't think we need a return to 0. But let's try. If it complains, we put a return to 0. Yep. So as beautiful as it is, it's just not showing properly. So let's do this. So I'm going to close this and I'll try again. And it just gives me exactly the same thing on the console as it gives me in the file itself. So 7 is divisible by 7. This is divisible by 7 all the way down to 2. Does it make sense so far? Do we want to try out this code, or are you happy for me to go on with more examples? Okay. Right. So if the number is prime, then of course we said prime to be true. And of course, if the number and we say n equals 2 into I minus 1 anyway. So if the number is divisible by 2, then we said it's not divisible by 2, then it's going to be false and everything. So if it's not prime, so if divisible by 2 is even, not prime. And again, we print out some things to the output and of course to the file as well. We can break it down, but basically quite similar to what we did for divisible by 7 by using the modulus operator. We are using of course 2 now. We can use a different thing as well. So please enter a positive integer and 800, and we do the same. So we notice it's created a file for prime2.test, and it has picked out all the prime numbers in prime2.test. It may not be the most efficient code. I may have to review it properly, but at least it does the job. Does this make sense to most of us? Are we happy to continue, or do you want to try it out yourself? Okay.
Okay.
So we create a variable that we call prime. So we ask the user to input a number. We take that number from the user and we call it num, which is saying that, which simply says we're going to count from 3 to that number. Yeah. So in my case, when let me delete. So when I run it, I put 800, or let's call it, let's use a bigger number, 8,000. That's what I put for myself. So we come back. So at the moment, at this point, we would take the 8,000 and then we would say we count from 3 to 8,000, right? And we're still inside the first for loop. So let me do this. Second for loop will go 1 indentation. Inside the second for loop, the contents that will run will go another indentation. All this run within the second for loop, right? So we have the second for loop ending here. Right, so we've entered the first for loop. It's a nested for loop, right? So the first, we say we're counting from 3 to 800. And each time we're going to say we set prime to be true for the first time. So we set prime to be true. Okay, then we start counting from 2 to the current I number. So when we start, I is what? I is 3. So I minus 1 is 2. So we count from 2 to 2. So it's just basically staying there. And we just check to say if the number is divisible by 2, or is this divisible by, well, if the number divided by 2 it returns 0, then it's not a prime number. Does that make sense? Yeah?
Yes.
Okay, so we check in all the number of what are prime numbers? Numbers divisible by 1 and only itself, isn't it?
Yes.
So in this case, we check in, we have a number. We're going to start from the minimum we can divide. No point to use 1 because 1 is every number is divisible by 1. So we take 2, count all the way to the number just before that particular number, and we check to see if there are multiple divisions over there. So if there are multiple, then it's not prime. If, of course, if there are none, then it's just going to be only 1 and the number itself. Then it means it's a prime number. So in this particular case, we check between 1 and the number just before that. Are there any numbers that are divisible by, that can divide that number? In that particular case, if yes, then it's not a prime number. If no, we've already set it to true as a prime number. So let's see where this for loop ends. That for loop ends there. So let me make it cleaner. Why does it keep doing that? Oh, I was doing the right thing. So then we come back, we are still inside the for loop. Remember, this for loop ends here. And then that for loop instead. So we have another if, right? So after we check this condition, we say that, okay, at this particular point in time, prime can be either false or prime can be true. So if it is a prime number, then we want to print out is a prime number. When we want to print out the number and then prime. If it is not prime, then of course we do nothing. Alternatively, we can do this and we just say it's not. It's not. So at the moment, we've got numbers, it's a lot. We've got numbers like 13, 17, 9, 2 being prime, right? So we have the, inside the file, we've got, oh, sorry, I didn't go all the way. We've got all the way 3, well, it's got pushed down. We've got 3, 7, blah, blah, blah inside the file all the way through 13 something because it got pushed up. Do a few times to get the code back to where it was. Just change the name of the wording for prime even, but at least the code make more sense now. So I'll go to the next slide, see if there are more things that I need to cover. Are you happy for me to continue? Has everybody finished the code? So this particular one, the unique thing about it is that, of course, we are creating a file path, but we don't have to worry about that now, or a path to a file. We don't have to worry about that now because we are using the online compiler, which saves to the server at the same time. And the rest basically is just to, of course, read from a file, with things that we, in terms of inputting from a file, we've already covered that in previous session. And I think that covers the remainder of this set of files. So it covers the main slides that I wanted to cover today. But my only advice, have some time, go through the examples, see all the different examples. Do have a play around the lines of code, but in terms of understanding the key things, those are the ones that I have walked through with you at the moment. So I'll pause the recording at this point